Picture this: water so hot it could melt metal, yet it doesn't boil. And this is not in some laboratory. It's thousands of meters beneath the ocean's surface, in a world of complete darkness, under pressures so immense they would crush a submarine like a soda can. It sounds like science fiction, but it's real. Beneath the waves lies a hidden world, one of superheated water, alien life, and chemical reactions that defy what we think is possible. A place where life doesn't rely on the sun, where heat and pressure create environments that seem straight out of a fantasy novel. Scientists call these marvels hydrothermal vents, but they are far more than vents. They are windows into the fiery heart of our planet, and perhaps even the birthplace of life itself. Today, we're not just exploring the ocean. We're uncovering a secret world that could change the way we see life, survival, and Earth itself. Before we dive deeper, smash that like button if you love mysteries of the deep sea, and comment below. Would you dare to explore a world where water is hotter than boiling, but the heat itself wouldn't even touch you? The ocean floor is alive. The ocean floor isn't just sand and rock, it's alive. Far beneath the waves, under thousands of meters of water, the Earth is constantly moving. Massive tectonic plates grind, collide, and pull apart. Magma rises from deep within the planet, heating the crust from below. And scattered across this dark, silent landscape are cracks, hidden passageways that lead straight into the Earth's fiery interior. Through these cracks, icy cold seawater begins a dangerous journey downward. It sinks deeper and deeper, pulled by gravity, until it reaches rocks heated to hundreds of degrees, hotter than any oven you've ever seen. The water doesn't just warm up, it transforms, absorbing heat and minerals from the rock itself, becoming something entirely different. Scientists call the places where this superheated water erupts back into the ocean hydrothermal vents, massive underwater geysers that blast mineral-rich fluid into the freezing deep sea. And here's the wild part. This water is so hot that if you could somehow bring it to the surface, it would boil instantly. Yet down here, under crushing pressure, it stays liquid. In 1977, aboard the submersible Alvin, scientists exploring the Galapagos Rift made a discovery that changed science forever. They didn't just find 400-degree water, they found life. Giant tube worms, ghostly shrimp, and strange bacteria thriving without sunlight, surviving in a world powered by heat and chemicals instead of the sun. How boiling water exists without boiling. Now here's the part that completely blows most people's minds. That water erupting from hydrothermal vents can reach temperatures of 400 degrees Celsius, hot enough to instantly boil water at the surface. And yet, it doesn't boil. No bubbles, no steam, just roaring jets of superheated fluid pouring into the dark ocean. So why doesn't it boil? The answer is depth. The ocean is deep, really deep. At 2,000 to 3,000 meters below the surface, the pressure is absolutely crushing. We're talking hundreds of times greater than the air pressure you feel right now. That pressure changes the rules of physics. Down here, water behaves in ways that seem impossible on land. The immense weight of the ocean presses down from every direction, squeezing the water so tightly that it physically can't turn into steam, even at temperatures that would vaporize it instantly on the surface. Think of it like this. At home, water boils at 100 degrees Celsius. But now imagine placing that water under a massive, invisible weight, heavier than mountains, heavier than entire cities. That's what deep sea pressure is like. It's essentially a pressure cooker the size of the ocean itself. Inside that cooker, water can become dangerously hot while staying liquid. No bubbling, no boiling, just raw, intense heat trapped under pressure. In some extreme cases, the water near these vents enters an even stranger state. Scientists call it superheated water, or sometimes a supercritical fluid. This is a rare form of matter that isn't quite a liquid and isn't quite a gas. It flows like a liquid, spreads like a gas, and dissolves minerals with terrifying efficiency. It's something you'll never see in your kitchen, but it exists naturally, right now, deep beneath the sea. Life in the extreme. You'd think life couldn't survive here, right? No sunlight, crushing pressure, water hot enough to melt metal just meters away. Everything about this environment screams impossible. And yet, the deep ocean delivers one of the most powerful lessons in biology. Nature always finds a way. Surrounding hydrothermal vents is an ecosystem so strange it looks alien. The water is pitch black. The pressure could crush a human instantly. Toxic chemicals like hydrogen sulfide pour out of the vents, the same gas that smells like rotten eggs and is deadly to us. And still, life not only survives here, it thrives. Meet the giant tube worm. These aren't the worms you find in your backyard. These creatures can grow over 2 meters long and live for decades in total darkness. They have no mouth, no stomach, no digestive system at all. Instead, their bright red plumes absorb chemicals from the vent water. Inside their bodies live billions of microscopic bacteria, tiny chemical factories that convert toxic compounds into usable energy. This process is called chemosynthesis. No sunlight, no photosynthesis, just heat, chemistry, and survival against all odds. And tube worms are just the beginning. Ghostly white crabs scuttle across the vents, feeding on bacteria growing on the rocks. Massive clams snap open and shut, filtering chemical-rich water. Shrimp with no functioning eyes sense heat instead of light, clustering dangerously close to boiling hot plumes because that's where the food is. This entire ecosystem runs on chemical energy, completely independent of the sun. Now here's where it gets deeply human. Scientists believe environments like this may be where life on Earth began. Billions of years ago, before plants, before animals, before oxygen filled the atmosphere, the planet was hostile and dark. Hydrothermal vents may have provided exactly what early life needed: heat, energy, and rich chemistry. The same reactions happening right now, deep beneath the ocean, could be echoes of the moment life first sparked into existence. Every time scientists descend to these vents, they're not just studying strange creatures, they're looking back in time, toward our own origins. Life didn't need sunshine. It didn't need calm oceans. It needed an opportunity. Hydrothermal vents around the world? Hydrothermal vents aren't rare, they're just hidden. Scattered across the ocean floor, tucked away in places humans can barely reach. These vents exist in some of the most extreme environments on Earth. From the moment scientists discovered the first vents, they realized something shocking. This wasn't an isolated miracle. It was a global system. Stretching like scars across the planet are mid-ocean ridges, massive underwater mountain chains where tectonic plates slowly pull apart. And wherever these ridges exist, hydrothermal vents often follow. One of the first places they were found was the Galapagos Rift. But since then, vents have been discovered along the Mid-Atlantic Ridge, the East Pacific Rise, the Indian Ocean, massive underwater mountain chains where tectonic plates slowly pull apart. And wherever these ridges exist, hydrothermal vents often follow. One of the first places they were found was the Galapagos Rift. But since then, vents have been discovered along the Mid-Atlantic Ridge, the East Pacific Rise, the Indian Ocean, and even in polar regions beneath icy waters. And here's what makes this even more fascinating. No two vent systems are exactly alike. Some vents are known as black smokers, towering chimneys that blast out dark, mineral-rich water loaded with iron and sulfur. These minerals cool instantly when they hit the cold ocean, forming smoky clouds that look like underwater volcanoes. Other vents are called white smokers. They're cooler, gentler, and release lighter-colored minerals like barium and calcium. Their chemistry is completely different, and so is the life they support. Each hydrothermal vent is like its own tiny planet. Different temperatures, different chemicals, different creatures. Some vents pulse violently, others flow quietly for centuries. Some shut down suddenly, while new ones burst to life nearby. The ocean floor is constantly changing, and these vents are living proof that Earth is still very much alive. In 2025, scientists made another astonishing discovery: a new hydrothermal vent system in the Mediterranean Sea. This one surprised researchers because it didn't fit the usual pattern. Instead of sitting along a massive ocean ridge, this vent system formed where methane-rich fluids mixed with hot water rising from below. The result was a chemical cocktail unlike anything seen before. Strange mineral structures grew in twisted shapes, and microscopic life flourished in conditions that would be lethal to humans. Even the animals there were different. Tiny shrimp-like creatures clustered around chemical plumes that would poison most life on Earth. Instead of avoiding danger, these creatures depended on it. To them, toxic chemicals weren't a threat, they were food. And that's what makes hydrothermal vents so powerful to study. Every new discovery rewrites what we think life needs to survive. Every expedition reminds scientists that Earth still holds places that feel truly alien, places where the rules are different, places we are only just beginning to understand. Science meets adventure. Exploring hydrothermal vents isn't just science, it's pure adventure. These places exist at depths where humans cannot survive for even a second. No air, crushing pressure, total darkness. To reach them, scientists rely on some of the most advanced technology ever built. Submersibles like Alvin and remotely operated vehicles known as ROVs act as our eyes and hands in the deep. They descend for hours, sinking through black water until the sun is nothing but a memory. Onboard cameras search the seafloor, robotic arms extend carefully, and scientists guide every movement from the surface, knowing that one wrong move could end a mission years in the making. When these machines reach a hydrothermal vent, the scene is unreal. Towering mineral chimneys rise from the seabed. Superheated water blasts out like an underwater storm. Life crowds dangerously close to temperatures that would instantly kill us. And in the middle of all this chaos, scientists begin their work collecting water samples hotter than boiling, chipping away pieces of newly formed rock, and sometimes capturing living organisms never seen before. On one unforgettable expedition, researchers measured water erupting from a vent at temperatures so extreme it became the hottest water ever recorded on Earth. According to everything scientists once believed, life should not have existed anywhere near it, and yet, just meters away, entire communities of organisms were thriving. Worms, microbes, and crustaceans living right at the edge of what biology was supposed to allow. That discovery forced scientists to rewrite textbooks and rethink the very limits of life itself. Every dive comes with risk. Equipment can fail. Communication can be lost. Weather on the surface can turn dangerous without warning. But the reward is discovery. Each expedition uncovers new chemistry, new species, and new questions that no one has answers to yet. Some organisms found near vents don't exist anywhere else on Earth. Some chemical reactions happening down there were once thought impossible outside a laboratory. This is what exploration really looks like: humans pushing technology to its limits to understand a world we were never meant to see. It's a reminder that even in the 21st century, there are still places on our own planet that feel completely unknown. The future of deep-sea exploration. Hydrothermal vents are more than just scientific curiosities hidden in the dark. They are windows into Earth's past, keys to our future, and blueprints for technologies we haven't even imagined yet. Every time we discover a new vent system, we're not just learning about the ocean, we're learning about life, about survival, and about our place in the universe. One of the biggest reasons scientists are so fascinated by these vents is what they can tell us about the origin of life. The organisms living here, known as extremophiles, thrive in conditions that would instantly kill most life on Earth. They don't need sunlight. They don't rely on oxygen. Instead, they use heat and chemicals to survive. By studying them, scientists can better understand how life may have first formed on our planet billions of years ago and where it might exist elsewhere today. This research directly fuels astrobiology, the search for life beyond Earth. Moons like Europa and Enceladus, icy worlds orbiting Jupiter and Saturn, are believed to have vast oceans hidden beneath their frozen surfaces. If hydrothermal vents exist there, Just like on Earth, they could potentially support life. The strange creatures living near our own deep sea vents might be the closest analog we have to alien life forms. In a way, every dive into Earth's deep ocean is a rehearsal for exploring other worlds. Hydrothermal vents also hold immense interest for their mineral resources. As superheated water erupts from the vents, it deposits metals like iron, copper, zinc, and even traces of gold onto the seafloor. Over time, these minerals build massive structures rich in valuable elements. Some see this as a potential resource for future industries, especially as demand for metals continues to grow. But this possibility also raises serious ethical questions. Should we mine these environments? Can we do it without destroying ecosystems we barely understand? These are debates that scientists, governments, and communities around the world are only beginning to have. Then there's the promise of medicine. Life near hydrothermal vents has evolved unique biochemical tools to survive extreme heat, pressure, and toxicity. Some of these organisms produce enzymes and compounds unlike anything found elsewhere on Earth. Researchers believe these could lead to breakthroughs in antibiotics, cancer treatments, and industrial enzymes that function under extreme conditions. In the past, life-saving medicines have come from plants and shallow sea organisms. The deep ocean may hold an even greater pharmaceutical treasure trove waiting to be discovered. Technology itself is also being shaped by deep-sea exploration. To study vents, scientists have had to invent machines that can withstand crushing pressure, freezing temperatures, and corrosive chemicals. These innovations don't stay underwater. They influence robotics, materials science, artificial intelligence, and even space exploration. The tools we build to explore the deepest parts of the ocean may one day help us explore the depths of other planets. But perhaps the most important part of the future of deep-sea exploration isn't technology or resources, it's us. It's curiosity. It's the shared sense of wonder that keeps humans asking questions and pushing boundaries. The ocean still covers more than 70% of our planet, and scientists estimate that over 80% of it remains unexplored. That means most of the story is still missing. Most of the discoveries haven't happened yet, and that's where this community comes in. We are living in an era where exploration doesn't belong only to a handful of scientists on ships. Through shared knowledge, discussion, and curiosity, we can follow every new discovery together. We can question the impact, debate the ethics, and imagine futures that balance progress with preservation. Hydrothermal vents remind us that even on our own planet, there are worlds that feel alien, places where the rules are different, and life rewrites the definition of what's possible. And as long as there are places like that left to explore, the story of Earth is far from finished. So, yes, deep beneath the ocean, in total darkness and under unimaginable pressure, there really is water hotter than boiling. Water that should turn to steam, but doesn't. Water that pours from the Earth's crust like an underwater inferno, yet somehow becomes the foundation for entire ecosystems. Hydrothermal vents are not myths. They are not science fiction. They are real, and they exist right now beneath the waves. They remind us that life is far more resilient than we ever imagined, that it doesn't need sunlight, calm seas, or gentle conditions to survive. All it needs is energy, opportunity, and time. In the most hostile environments on Earth, where heat, pressure, and toxicity collide, life finds a way to adapt, evolve, and thrive. And in doing so, it challenges everything we thought we knew about biology, survival, and the limits of nature. These hidden worlds beneath the ocean force us to rethink our planet's story. They offer clues about how life may have begun billions of years ago, long before forests, animals, or even oxygen filled the atmosphere. They help us imagine where life might exist beyond Earth, in the dark oceans of distant moons. And they remind us that exploration isn't finished, not even close. Despite satellites, maps, and modern technology, the vast majority of the ocean remains unexplored. Entire ecosystems, species, and discoveries are still waiting in the dark. Somewhere beneath the waves right now, something exists that no human has ever seen. And that idea alone should fill us with wonder. wonder. Hydrothermal vents are proof that our planet is still alive, still changing, and still full of secrets. They show us that the greatest discoveries don't always lie above us in the stars sometimes. They're hidden deep below, in places we're only just beginning to understand. Call to action. If you loved this journey into the ocean's hidden furnace, hit that subscribe button and ring the bell so you don't miss what we explore next. Join this growing community of curious minds and explorers because the unknown is always more exciting when we uncover it together. And before you go, drop a comment below. Which hydrothermal vent, creature, or discovery amazed you the most? Let's keep the conversation going.